So to save our data, we're going to use CME 8.0. So as you can see, I'm using a ASP9036. This is a DSP based drive, and we need to migrate the information, you know, tuning parameters of the current loop, velocity loop, also information related to the position loop, as well as all the selections for the basic settings. We need to migrate it to a new drive. In this case, it's going to be a FPGA based drive, which is BEL. Um, so all these selections we need to um, migrate to the new drive. So to start the process, we're going to go to File, Save Amplifier Data, CCX file, and we're going to name this ASP migration file. Okay. Another thing that we need to save is the uh, motor configuration, the motor, all the information, all the good data for this specific motor, we need to save. So we're gonna select the um, model number of the motor. I'm gonna do Control C to copy that. Click this floppy disk at the bottom, and I'm gonna name this ASP, which is because that's the drive we're using right now. Parker, because that's the maker of the motor, and this is the model number. Control V to copy. Then we save, and we save all the information related to this motor to a motor file. In order to start migrating all the information, what we're gonna do is we are going to open two different sessions of CME. Okay. On the very first one, we're gonna go to Virtual Amplifier, select Open Existing Amplifier CCX file, and we're gonna search for the file that we saved minutes ago, ASP migration file. So this file has the basic configuration, all the values the customer used to tune his motor. So we're gonna keep this here. Then we're gonna open a new session of CME. All right, we're gonna move to the side here. Go to Virtual Amplifier. Create new virtual amplifier. In this case, we're going to use a BEL. All right. So what we do here is we open the settings on the file that we saved previously, and basically we copy everything here, from here to here. So same selections. Just click next, next. Also digital, Hall, phase correction, incremental. These are the defaults. In this case, these are the defaults of CME. That's why. But if you use you're using a different encoder, or you don't have halls, for example, just obviously the idea is to copy exactly what you have here on the left-hand side to the right-hand side. 1,000 lines, 4,000 counts. This is an older drive, so there's some options. There's nothing here anyhow, but see how this drive, some options you're gonna see on the right hand side are not available on the left hand side. So we do the best to copy all we can. So it's going to be in position. This one has a digital input because this customer is using pulse and direction. So, okay, next. Customer is using sinusoidal commutation mode. Okay, and we can leave the buffer primer feedback out. Doesn't really matter. Okay, so we're gonna do finish. Okay, so our basics configuration of the drive of the new BEL drives is ready. Now we need data. So now we're gonna open the motor tab, open the file, and we save this as ASP Parker. That's the drive, the motor. I mean the motor file, and we can check to see if all the data is the same. As you can see, it's not the same, but it's just basically because the file, the original file, is in metric, is in English, and I have it in metric. So now it should be the same. I change it. We verify that everything is the same. Yep. All right. And we close this. So now the most important part is check the loops. Um, like like I said, these values, for example, 3500 and 200, these were values of the customer already input because they tuned their system. Oh, I forgot to, let's go back to the motor tab. Let's press the calculator here on the right hand side. So it actually applies some values to the loop. See, gonna just do it because it's less information to, that you have to input. So this is 3500 and this value is 200. All right, we're done with that. Then in the velocity loop, we have that one's correct. This is all correct. This is 150 and this is 50. The window threshold 45. I don't know how relevant this will be. In this case, 3.67. Let's copy it. Okay. So the file size are identical. Position loop. Here should be everything should be about the same. Yeah, everything is the same. Trajectory values. Well, like I said, everything should be here the same. Although this customer is doing pulse and direction, so it shouldn't be, actually these values should be clear out, but we'll leave it to them. Next, we're gonna check, as you can see here, and IN5 and IN6 are pulse and directions. And here IN5 and 6 are also pulse and direction. That's basically it. We managed to copy all the information from the ASP drive, which is a DSP based drive, to a BEL drive, which is an FPGA based drive, basically in what, 3 minutes, 4 minutes, something like that. It's extremely easy. Keep in mind that once you download the new CCX file into your drive, some additional tuning might be necessary. But in general terms, this configuration should work right off the bat. Okay, that's all. It's pretty simple. Oh, and if I forget, you need to save this, the new file. So we're gonna call it BEL with Parker motor, I guess. You can name it whatever you want. That's all. Thank you.